Hello. Hello. അതെ സ്ട്രീം ചെയ്യുന്നുണ്ടോ? ഒന്ന് നോക്കിക്കേ. ആ ഞാൻ ഇവിടെ ലൈവ് സ്റ്റാർട്ട് ചെയ്തിട്ടുണ്ട്, പക്ഷെ സ്റ്റാർട്ട് ആയോന്ന് എനിക്ക് സംശയമുണ്ട്, കാരണം എന്തൊക്കെയോ കാണിക്കുന്നുണ്ട് ഇതില്. ആണോ? ഞാൻ പറയുന്നത് കേൾക്കുന്നുണ്ടോ? Today we will be dealing with Python Advanced. Okay. Hello. Can you please let me know if I'm audible? Okay, so since from yesterday's class, I got a feedback that most of you are beginners to the course, and I wanted to show you some Python code before we move on to generative models and deep learning. Okay, so we'll be starting with our uh, variational autoencoders today. I have the code here, right here. So we'll be building a VAE today using the MNIST dataset. So before moving on to that, we'll be dealing with some advanced Python. Okay. Yeah. So basically, I'll be sharing this Jupyter notebook in the description once the live has ended. Also, I have some handwritten notes of the previous lecture that was bootcamp day one. I have the written notes. I'll upload a link of that as well uh, in that particular description as well. Okay. So basically, here we'll be dealing with some advanced Python. I expect you to know basic libraries and functions. Okay, we'll basically be moving on to the Python for machine learning part. Before that, we'll just have a quick go through. Okay, don't worry about this. I'm just setting the path of this particular notebook so that it won't strike errors in later part. When I share this notebook with you, please do update the path as your current working directory before moving on. Okay. Yeah. So As you can see, I've defined a function called function Python, which takes n as an input parameter. I've set a variable d as 0. I've iterated over the range 0 to n minus 1. What I'm doing is I'm uh, incrementing the value of d by I mod 3 minus 1 into I. Okay. Modulus operator, as you know, is returns the remainder between two operands. So the remainder you get when you divide I by 3 minus 1 into I will give you uh, that particular value is getting appended to D, and I'm returning that particular value. Let me just execute it and I'll show you. Yeah. So I've the function has been executed. You might be wondering why there is no output, because I'm just returning the value of D. I'm not printing it anywhere. If I use it at a later stage, it will the function will be printed. Okay. Uh, when I come to the next line of code, you can see I've used a percentage time uh, command. I have invoked the function my function with a parameter of 10,000. Let's see what it returns. Yeah, the code is still executing. It's some big thing happening there. That's why it's taking time. Yeah, you can see that it's basically to check the speed of the uh, how fast it is getting executed. So 1.47 millisecond is the time taken to execute this particular function. A function when the value of n is 10,000. Okay. Yeah. So basically, let's see some code. Let's see some advantages and disadvantages of not using any particular library. So here, as you can see, I have a distance list. I have a speed list. I need to calculate time. So the equation to calculate time is distance by speed. Distance and speed are two lists that I have here. So just look at the code. If I say time is equal to distance by speed, uh, one might expect you to divide 45 by 5, 50 by 10, and 35 by 7 and return all the answers to time. But that is not going to happen. This particular code is going to give me error, because simply giving distance by speed will not return a list containing all the quotients as time. That is not going to happen here. Yeah, see, it has returned a type error, right? So how will I have to correct this particular code? I have to declare a list called time. I have to iterate over both the lists. I'm the distance list and the speed list. I have to append the time value to the corresponding time value to the time list and then execute it. Only then I'll get this result. But what if I say you can get this code executed? You can get this code executed. How? For that, we'll be using some Python libraries. Okay, so you can see this particular code block is just 4 lines long, whereas this is 6 lines long. So you can see the complexity. You can compare the complexity of the two codes, right? So using libraries, we are going to make this particular code executable. Let's see how. Okay, for that we'll be using NumPy package, which stands for numerical Python. Let's see what are the advantages. So NumPy, basically short form for numerical Python, it's a very basic package that we commonly use for scientific computing and data analysis. So when we come to data analysis and scientific computing and all, you can't write lengthy codes explaining all with all those iterations and all. You need shortcut or clear cut methods of doing things. So for that we have NumPy package in Python. So first of all, let's import NumPy. I've aliased the package as np, so I'll be using np throughout. Okay, yeah. So from NumPy, I am importing two modules called array and a range. Let's execute that. Now, I am converting. So earlier I have declared my distance and speed lists above. So what I'm doing is I'm converting the two lists to array. Okay, I'm converting distance list to an array and storing it in dist. I am converting my speed list into an array and storing in speed. Okay, and I'm printing it here. I'm calculating time as distance by speed as I did above. I'm printing it, and let's see what is going to happen here. Yeah, see what happened. So in order to create an array out of NumPy, you either have to give just array of distance, or you may use this np.array. Both works. That's what I wanted to show you. And giving np.array and just array works. Okay. Yeah. So this is how an array in Python looks like. Can you identify the difference between array and a list in Python? It's very obvious, right? There is no, what do you say? There is no comma in between the values. Comma values are separated by a comma in a list, whereas in NumPy or using an array, it is just spaces. Okay, and while representing matrices and all, we use NumPy mostly. Okay, I mean array. NumPy for calculations, and array as the data structure. Okay, so as you can see, when I just gave time equal to distance by speed, I got it all divided. The corresponding values got divided. 45 by 5 returned 9.9 means 9.0. Earlier when we did use, you can see it gave me 9.0, 5.0, 5.0. Similarly here 9.5.5 point. Okay, that's how you get the output. Okay, this three, it's basically the length of the time array. Time is also an array here because distance and speed both are array data types. So time will also be a array data type. Okay, now coming down, uh, you can see two lists A and B. I am adding the two lists. Do you think that will work? Any idea? Let's see how will it work or not. I'll just comment out the other part. Okay, let's see if that works. Yeah, you can see it has worked. So lists can be added in Python. When I gave a plus b, the elements in b got added to the elements in b got added to the list a. Okay, 1 2 3 4 5 10 20 30 40. That's how the result came. Now when we let's see if I can add just a value. Okay, let's see if I can execute this. No, I cannot add that. I cannot do that. Why was I able to add A and B? Because both are of the same data type. Both are lists. That is why I could add A and B. But then I couldn't add A and 5 because A is a list and 5 is just an integer. I cannot add a list and an integer. Okay, that's why it gave me a type error. Okay, so how can I add 5? We'll look at that. We'll basically a person who knows list operations will know the method to add an integer or add a single value to a list is using the append function. Okay, if I give append, I'll get it added. I have to display a as well. Yeah. See, uh, I have appended 5 to the end of the list A, and that is how I got it here. Okay. I hope that's clear. Now let's have a look at this part as well. So what's this basically? Uh, so as you can see, C is a list because it's enclosed in square brackets. So it is a list. What I'm doing is val plus 5 for all val in A. That means let's look at this part for val in A, which means that I'm iterating over the elements in A. Okay. So val is the variable name. So val takes the values 1, 2, 3, 4, 5 in each iteration. Okay. So what is getting stored in the list is val plus 5. Okay. So if you need to create a list containing values in some particular order or following a sequence, you can use this type of statements. Val plus 5 for val in A is how I've given it here. Okay. So what will get printed here? Basically the values in A plus 5. Okay, let's see if that's the case. Yes, 1 plus 5, 2 plus 5, 3 plus 5, 4 plus 5, and 5 plus 5 is what is getting printed here. Okay, I hope you got that. So moving on. Yeah. So what we'll be dealing here is I'm converting the two lists A and B into an array. Okay, let's see how we will be getting it. I'm just commenting this part because that's required at the later stage. Okay, let's see if f plus g gets executed. No. So as you can see, two arrays cannot be added. Okay. If you want, we'll check the data type. So how to check the data type of something? Just use the type of function. Okay. We'll yeah. The type of f and g will be numpy.nd array. Okay. Nd array means n dimensional array. So you cannot, so from executing this particular statement, what did you understand? We saw that you cannot add two arrays in numpy. Okay. So how will we overcome that? We'll see. Now let's see if we can add an integer value to the array. Let's execute it. Yes, here you see what happens. F plus 5. So when I gave f plus 5, each value in the array got incremented by 5. Okay, what we expected was to add 5 to the end of the array, but what happened is each value in 5 got incremented by 5. Okay, so when using list, I had to write this particular statement in order to increment the value of each element in a list by 5. But while using array, you just have to do array plus 5. Okay, I hope you got the difference. Now let's see if we can do f star star 2. F star star 2 is nothing but f raised to 2. So if f plus 5 increments each element's value by 5, then what will f exponent 2 do? We expect each element to get squared, right? So this is basically f squared. So we expect each value in the array to get squared. Let's see what we get. Yes, we've got the squares, right? See, 1, 4, 9, 16, 25. 1, 2, 3, 4, 5. All the elements squared will give you this. Okay, let's see if g cube will get executed. Yes, that also is executed. You can see 10 cube, 20 cube, 30 cube, and 40 cube. Okay, so we've seen how to deal with that. So let's see how the a range function works here. A range is another function. Let's execute this and see. So what has happened here is array a range 10. So a range 10 means array of a range 10 means I am creating an array of numbers from 0 to 9. A range 10 will return values uh, less than 10, which is 0 to 9, integers less than 10, 0 1 2 3 up to 9. So I'm creating an array out of it and I've got it here. Okay, now I'm using another method, np.arange of 556 5. Okay, let's see what uh, will be displayed. So while working with you know, lists and all, we have seen, we know the function range, right? What does range do? Similarly, it in the particular, in the specified range, it produces numbers within the range, right? So what is being done here? So similarly, a range also generates values in a given range. So this 5 is the start value, 56 is the end value, and 5 is the step value. Okay, so what will be the uh, what will this particular statement return? It will return 5, 10, 15 up to 55. As you can see here, see, this is the output. Okay, that's how a range function works. Here we have only given the end value. By default, the start value is 0. By default, the step value is 1, similar to the range function. A range function also has start, stop, and step values. Okay, I hope that's clear. Okay, now let's see one more method to do it. So let's see what is being done here. Okay, so linspace. What this particular method in NumPy does is, in a given range or in between two numbers, it generates count number of numbers, which means the range given by the user is 3 and 4. Start value is 3, stop value is 4, and the number of numbers, okay, to be generated in between 3 and 4 is 13, which means I have to generate 13 numbers in between 3 and 4. Obviously it will be decimal numbers. Okay, so that's how the linspace function works. You can see here 3, 3.08333, etc, etc, and you can see 13 numbers being displayed between 3 and 4, both inclusive. Okay, so in between 3 and 4, there will be only 11 numbers, including 3 and 4, there will be 13. Okay, you can read the comment over here. I've given comments for all code, so you can refer to that as well. Okay, so if you want me to show how to round off numbers, we have created this one more array. One more array means this particular thing. Okay, we are rounding off the values. Okay, rounding off the values to the 0th decimal place. So this is the output that you get. If you just go through this and just see how the rounding off works, you will get clear with that. Okay, yeah. Now we'll see some important methods like reshape and reshape, shape, detype, size, and all. So how reshape works is, so we'll not be dealing with this part here. So what reshape does is, I can, you know, change the dimensions of a given array using reshape. Okay, here I'm giving, okay, this is my np dot array of this. This is a very big array that I'm creating. This will be an uh, you know, something by one dimension, because I've entered only one row. I need to reshape it as, if you can see here, I need to reshape it as, okay, I'll have to comment these out, only then the other things will work. Okay, so I need to reshape this given array as as an array containing 8 rows and 3 columns. Okay, how will I do that? Let's see. How will you do that? Means you can use the reshape function. Let's see what output we are getting. See, reshape 8 comma 3, 3 columns, 8 rows. Okay, so I hope you got how the reshape function works. I ended it as just a single array, and using the reshape function I created a matrix containing 8 rows and 3 columns. Okay, now let's see this data 2 as well. It's not required. Okay, let's see data 2 as well. I'm here, I have 4 parameters, and let's see how that is going to be executed. See, as you can see, this is creating, this was a two-dimensional array, but now this has become a four-dimensional array. Okay, you can see this here. See, 1, 2, 3, 4. Okay, the number of parameters that I give here is 4. That's why I said it's a four-dimensional array. Here I have two parameters, and hence it is a two-dimensional array. Okay, you can play with code like this in your free time. So yeah. So this is how you do the reshape thing. Okay. Now let's try and display what is the uh, shape function. Let's see how shape function works, or what is the functionality. Shape function, what it basically does is it it will display the dimensions of your data. Okay. See, this is the dimension, 2 by 2 by 2 by 3, 4 dimensions. Okay. Similarly, let's see what is the data type of data 2. It is int 32. Okay, now let's print size as well. The size is 24. Okay, so that's how all these methods work. Okay, it was just a demonstration of that. Okay, now I have another method called zeros, np.zeros. What it basically does is, let's see, it basically creates an array with zeros 50 times. It creates an array that has 50 zeros in it. Okay, that's how this np.zeros function works. Okay, now coming here, see, np.zeros 3 comma 5, 3 comma 5 is the dimensions. I need 3 rows and 5 columns of zeros plus 6. I'm adding a 6 to it. So what does it return? 6. Okay, so since the dimension is 3 comma 5, there will be 15 values, as you all know. So 3 rows and 5 columns, and that's how it works. Now similar to zeros, I have the ones method as well. But create with ones of 30 indicates that there will be 30 ones in the output. Okay, 31 numbered single dimensional array is what is being uh, returned. Okay, when I add 7 to it, you can guess it. 7 will be displayed 30 times, or the array will contain 30 sevens. Okay, sorry, it was when, if it is 0 you'll get 7, but since it's ones, 1 plus 7 is 8, so you get 8s in the array. Okay, now let's have a look at this as well. So can you make a guess what will it return? Yeah, it will return a two-dimensional array containing 5 rows and 9 columns. Let's just execute it and see. Yeah, you got it there. Okay, now what is this I function? I function basically creates an identity matrix of the given rank. The rank given is, or the dimension given is 5. So let's execute it. Yeah, I got an identity matrix. Okay, yeah. So how can you just enter the diagonal elements in a given in a given matrix? So you have the uh, method of diag, diag, diagonal. Okay, the array that I am entering will be the diagonal elements of the matrix. Let's see. See, 1, 3, 5, 3, 4, 5 is the diagonal elements of the returned matrix. Okay, so that's basically about NumPy. So these are basically the most common or uh, you know the most used methods or functions in NumPy. Okay, this notebook will be shared with you. Yeah. So let's come to pandas as well. So, pandas is basically the full form of pandas is panel data analysis. It is a very fundamental package which we use for relational data structures. Okay, while handling with uh, Excel, CSV files, SQL type of files and all. Okay, so when working with cross-sectional time series or panel data analysis, we use pandas. Okay. So yeah, if you don't have Python, sorry, Pandas installed in it, you can go to the package manager and install it. Okay. Now let's import Pandas and I'm aliasing it to PD. Okay. I need NumPy here as well. We'll see why NumPy is used here. Okay. Now my first method is series. PD.series. Let's see what it prints. Okay. So basically, series in pandas is similar to a one-dimensional NumPy array. Okay, you can see 10, 20, 30 got executed. But since it's pandas, what comes additionally is the indices. You can see the index is getting printed here. Okay, and that's one difference that pandas has from NumPy. In NumPy, I just have to do np.array and enter it as a tuple. But in pandas, what you do is pd.series. Okay. Now, I have this particular series in of variable series 1. I'm displaying series 1 dot values, and I've got it like this. I've got the 10, 20, 30, 40 array. Okay. Now, next command is index. Basically prints all these indexes. Yeah. The start index, stop index, and the step index. So the ranges for this particular series goes from 0 to 3. 0, 1, 2, 3. Step value is 4, which is excluded. Step value is 1. Okay, I hope you got that. Now here in the series method, I can my first parameter is an array, and I can give an additional parameter which is absolutely optional, which is the index parameter. Okay, let's see how it will get executed. So what is being done is I'm by default the indices will be, as you can see here, 0 to length minus 1, but here I'm explicitly mentioning that my indices should be 1 to 5. Okay, and that's how it came. Indices from 1 to 5, values unchanged. Okay, so if I try to display the value at sixth index, there is nothing in the sixth index. Only 1, 2, 3, 4, 5 is there. So if I give series 5, let's see. Yeah. So if my normal indices were 0 to 4, series 2 of 5 will give an error. But since the indices are 1 to 5, series 2 of 5 will give me the value corresponding to index 5, which is 50 here. Okay. Yeah. So let's try executing this as well. Series 2 of 3. This is an error. Okay. Yeah, you cannot explicitly give the element directly since it's indexing. Since it's slicing, you have to give the index itself. Okay. Let's see what will get printed here. So also turns the key error. You cannot give the you know number names. You have to give the names itself. Yeah. So series 2 plus 4, similar to what we saw in NumPy, adding an integer to an array directly will increment every value in the given array by the constant. Okay, here I'm adding 4 to each and every element in series 2. You can see the output here. Okay, now next code, I'm trying to find the cube of every element, and see, you got the output here. Okay, series 2 of series 2 greater than 30. What I'm trying to do is I'm trying to find all values greater than 30. Okay, and this is how it gets executed. Now here using the sqrt function is basically from the numpy package. Okay, I did not put it here, I think put it above. Let's see how it gets executed. So sqrt function of series 2 will return the square root of each and every element in the series. Okay, now sqrt method is included in the numpy package. Okay, that's why I've given np.sqrt off. Okay, yeah. So in the next code block, if you look at, I have a list called years. I have a dictionary F1. I'm trying to convert this particular dictionary into a series, and my indices will be these years. Okay, let's see how it's gonna turn out. So using these indices, I've created a series. Okay, yeah. Let's try to execute this as well. See, NaN. This is something that we will come across in machine learning. You don't have a value corresponding to 91. There is no value corresponding to it. That's why you got an NaN. Okay, it indicates a missing value. Okay, not applicable. You say Na. Yeah. So in pandas, NaN means missing value. Okay, NaN does not correspond to 0. Okay, it's basically null, or what do you say, a missing value, null value. Okay, nan is basically a null value. Okay, now firm 2, I have got some null values here. I'm trying to see if see pd dot is null will give true if there is some value, false if the value corresponding is, if there is a integer corresponding, I'll get false. If there is if it's a null value, I'll get true. Okay, because I've used the is null command. Okay, now here I'm again converting two dictionaries to series. Let's see, I've created a series out of it, this dictionary. So my first column is the keys and my second column is the values. Okay, so let's count 1 and count 2 are series. Let's try adding these two series. See, let see what has returned. Compensation, debt, earning, finance. So basically, the union is being taken. Uh, okay. So count 1